One of the most challenging parts of front-end web development is building interactive UIs, primarily due to the fact that your HTML and JavaScript are separated into different files. And it can become really complicated and cumbersome when you have to reference all the DOM elements by query selector, and then insert HTML elements to the DOM with template literals. And that is not to mention all the issues you will face passing state from one page to another, and as the changing state of your application increases, so does complexity. And that is where React comes in. How it works is you have an empty HTML file with nothing but a div tag, and from this div tag, React will take over, inserting all the DOM elements with JavaScript code that nobody dares to use. And how it does this is you create a function that contains all your HTML code inside of the function's return statement. Now this code might look weird to you at first glance, but this code is much more efficient than writing out the HTML inside of your HTML document, for reasons we will discuss throughout this video. And don't you worry, because by the end of this video you would be more than comfortable using code like this. Now this video is beginner friendly, so I'm assuming you are completely brand new to React. And as a beginner, I'm going to take you from complete noob to building an entire memory game from scratch. All I ask in return is to like this video and subscribe to the channel, and let's get started in React. To get started, as always, I will assume you have Node.js installed, and then from VS Code inside of my terminal I'm going to run npx create react app followed by the name of the app. Now it might take a few moments to install, so I'm just going to take a coffee break. Now once installed, inside of your project directory you will see you have a list of documents that have been created, and inside of the terminal it will tell you how to run your application, and over here it's telling me to cd into my project directory and then run npm start. And once my project starts up, it will run on localhost and it will display to you the basic boilerplate along with the React documentation. Now at the moment we don't really care about the React documentation because we're watching this video right now. So back into VS Code, I want you to go into the source directory and then into the app.js file. This HTML in the app file was the JavaScript code that we've seen running inside of the browser. So I'm just going to go ahead and remove this code and just change it with hello React. Now if I go ahead and save it and check it in my browser, you'll see hello React will display on the browser. Now before we get into the file structure of React, the first thing I want to talk about is what is a component. Now everything in React is essentially a component. And we might have the main component, typically called the app component, made up of multiple smaller components. For example, we would have the nav component, the main section component, and also the footer component. Now the nav component could be made up of smaller components as well, for example a button component, and each button would have its own code, its own JavaScript, and its own functionality. Now this component is the main app component, but I could go ahead and place another component inside of it. And in order to do that, all I need to do is create a function, and I'll call this function child component. Then this child component function will have a return statement, and this return statement will have the HTML inside of it. So now if I go ahead and save it and check it inside of the browser, you will notice that the p tag that I've just created is not showing up on the screen. And that is because I will need to place this component inside of my return statement of the parent component. And in order to do that, you need to call this function as if it were its own tag. And this tag will be called child component. And now if I check it inside of the browser, congratulations, you've just created your very first component. Now the main reason you would want to write code like this is say I wanted this p tag to be displayed in multiple places in my application. All I have to do is place this component wherever I want inside of a parent component, and just like that, my p tag will be in multiple places. Now here's the thing, all of these components are kind of boring. I mean, they're not really doing anything. And that is where we get into the next topic of this video, and that is hooks and state. Now React comes with a bunch of built-in hooks, and these hooks are nothing more than functions that give React a functionality that otherwise without it, it will be very difficult to implement certain features. Now I do have a playlist dedicated to React hooks that I'm currently updating, but the hook that we want to focus on is useState, which is by far the most important hook in React. And in order to use it, all we need to do is import the useState function from React. Now, the thing about React is whenever we want to place a value inside of our JSX that will change later on, we cannot use a regular variable, we would have to use state. And in order to use the state, we need to call the useState function. Now the useState function takes in one argument, and that is the initial value of the state. And I'll just go ahead and place in there 0. And the useState hook returns two values that can be destructured inside of an array. The first value is the actual state, and you could call it whatever you want, but I'll just call it state, and the second value is usually the same name as the first value but prefixed with the word set, and in my case it is set state. Now this state is the actual value, which is 0, and the set state is a function that you use to change the value of the state. And in order to change the value of the state, I'm just going to create a button, and inside of it I'm going to pass an onClick event. Now the onClick event will be set equal to these curly brackets, and these curly brackets will take in a function. So I'll just provide to it an arrow function, and inside of the arrow function I will call set state, which takes in one argument, and that is the state plus 1 to increment the state. Now what I can do is place the value of the state inside of my h1 tag, and once I save it and check it inside of the browser, each time I press add 1, the value of the h1 tag will increment. Now before we start building out our memory game, there is one more concept I want to show you, and that is the idea of props. You see, if I decide to use this state and try to place it inside of my p tag and just save it and open up my browser, you will see I will get an error telling me that state is not defined. And that is because the state exists within the app component and does not exist in the child component. And the thing about hooks is they must exist within a component, because if I use it anywhere outside the component, I will get another error telling me that use state cannot be used outside the component as it is a hook, and hooks must exist within a component. So the solution to this is, if I wanted the state to be passed down to every single component, we can pass the state down as props. And the best way to do that is by giving our component, once we call it, a value, for example state, and those curly brackets would have the state in it. Now if I repeat this for every single component and then save it and check inside of my browser, you will notice that state is still not defined. And that's because this component is actually still at its core a function. And whenever we call this component, we are essentially calling a function. And these props are essentially properties being passed down to the function as arguments. And I could essentially add multiple of these, and every single prop will be passed down to this component on a props object. But usually we don't like to call this props object, so instead we destructure all the props directly from the arguments. And now if I save React and open up my browser, you will notice all my components will be updated according to the state. Now one thing I would like to mention before we move on to the next topic, and perhaps you may have already noticed this, and that is everything that is dynamic inside of our JSX will go inside of curly braces. Kind of like how $ curly braces is a dynamic value inside of a template literal. Now there's one more thing I would like to show you before building our memory game, and that is the file structure of React. Now before I even show you the file structure, I'm just going to remove certain things that will just clutter up the space, because we don't really need them to build our project. Now inside of the app.js file, all the code that we've been writing so far has been displayed inside of the browser. I built certain components and they showed up immediately. But the question is, how exactly is this happening? Well, if you take a look at the bottom of the file, we are exporting the app component. And this app component is being imported inside of the index.js file. Once imported, we are going to call a render method and pass the render method the app component, which gets fed into the React DOM.createRoot. Now createRoot takes in one argument, and that is the element that we want to inject our React into. And in this case it is document.getElementById, and we're getting an element with the ID of root. Well, if we go into the public folder inside of the index.html file, we will find a div tag with the ID of root. This is where React will inject all of its components. Now you don't need to really know all of this to know React. The reason why I'm showing you is because A, you get to show it off to your friends, and B, I want to show you the files that you don't want to delete so we can remove any additional files that's just cluttering up the space. Things such as this setup.test.js file, the app.test.js file, all of these are just extra files there we're not going to cover in this video. You might want to use them later on in the future, but for now we don't really need them. And now that our source directory is all cleaned up, we should have two CSS files, an app.js file and an index.js file. And all the code that we'll be writing for React will be inside of the source directory. Any additional JavaScript files will also be in there as well. Aside from the source directory, we'll have the public directory where all the static images and logos will live, including the index.html file, and we'll also have the node modules folder. Now if you are not familiar with Node.js, the node modules folder is a folder you don't want to mess with. You're just going to leave it as is, and you never want to change anything inside of it. This is where all the code that makes up React will live. So we don't want to be playing with that, because otherwise React might stop working. Now, how Node.js knows which dependencies we have installed is based upon this package.json file. The package.json file will contain a list of dependencies for our application to run. And in the beginning of this video, we installed with npm React, so it installed the React dependencies. It will also contain the scripts to start up our application, like when we used npm start, and if we want to build our application for production, we'll run npm build. Now, gitignore is beyond the scope of this video, so we are going to ignore gitignore. Get it? And now that we've completed our walkthrough of the file structure, back in our app.js file, we can start building our memory game. So I'm just going to remove all the additional dummy code that we used for examples and start off with a fresh component. And inside of my source directory, I'm going to create a new folder and call it components. And inside of the components folder, I'll create a file called cards.js. And inside of our cards.js file, we want to export a function as a component called cards, and we want to return an empty div tag with the class name of container. And card.js will export a function as a component called card, which will return an empty div tag with the class name of card. Now, essentially, the structure of our application would be something like this. We'll have our main application, and the main application will have a cards component. The cards component will contain all the cards, and each individual card will be its own component. So we're going to start off inside of the app component, as it is the outermost shell that is holding up all the smaller components. So inside of the app component, I'm first going to add a h1 tag with Game of Thrones, because this is a Game of Thrones memory game. Then I'm going to add the cards component. And in order to add the cards component, I will also need to import it from components/cards. Now I can go to the cards component and start adding the boilerplate for the actual cards. Now here's the thing, every single card in this game will have its own image. And my public directory does not have any images in it. But luckily, I've already created a folder on my desktop with all the images inside of it, so I'm just going to place the images inside of my public directory. And now that I have the images in my project, I can now use them inside of my cards component. And on a side note, all these images are numbered with the correct ratio, so if you want to download them, you can get it from my GitHub page, link in the description below. And now the first thing I want to do inside of the cards component is create a state for every single card. And in order to do that, I'm going to create a state called cards, and it will have a function to set the states called setCards. Now this state will be an array of objects, and the properties inside of the objects will be the ID of the card, the name of the person in the card, and it will also have a status set to an empty string and which image it belongs to. And I will practically do this for every single card twice. So as you can see, we have 8 images but 16 cards, and each card will have its ID in relation to which image it belongs to. And I'm not sure if you've noticed this, but I've got the actor who plays Walter White from Breaking Bad listed on the names, and I'm not sure why, so I'm just going to go ahead and change the names to the corresponding characters from Game of Thrones and not Breaking Bad. And now that we've listed all our cards in the state, we want to now loop through every single card in the state and make it its own component as a card component. And in order to do that, we need to place curly brackets inside of the return statement of our component, because whatever goes inside of the curly bracket is dynamic. And we want to loop through the cards state. So I'm going to call cards.map. And this is a method that we will be using a lot in React whenever we want to loop through multiple items and return them to the DOM. So cards.map will take in a function, and the map method will give us 2 properties which we will need to use to render the cards. The first is the card itself, and the second is the index of the card. Now the index of the card is not the same as the ID. Where the ID is 7 for both cards, the index for the first card will be 0, but the index for the second card will be 1. So now inside of the cards.map method, we want to loop through the state and insert the state inside of the card component. So first we're going to import useState so we don't get an error when using it, and I'm also going to import the card component. Next, I'm going to return some JSX, and what I want to return is the card component. Now the card component will take in a prop, and I'll call this prop card, and that will take in the card that I've received from the cards.map method. Now inside of card.js, I'm going to place the boilerplate for the card itself. And so I'm going to grab the prop that I received from the parent component, which is the card, and I'll place an image tag inside of the JSX, and I'll set as the source of the image card.image. And as for the alt, I'll provide the card.name in case the image does not load. Now if I go ahead and save it and check it out inside of the browser, you will see that all the images have loaded in a sequential order. But obviously this does not look like a card game, and therefore styles will be required. Now this is not a styling tutorial, so I'm just going to copy the code from my GitHub page and paste it inside of my index.css file. And now if I open up the browser again, you'll see that I have 16 cards being displayed. Now obviously at this point the cards aren't doing anything, they are obviously not flipping, and another problem is that the cards are in the same order. So first thing I want to do is I want to shuffle these cards in a random order. Keywords random and order. So in order to do that, I'm going to go to the array of cards that we have in our state, and I'm just going to provide a .sort method on it. And the .sort method requires one argument, which is a positive or a negative number. If the number is positive, it will sort the array in an ascending order, and if the number is negative, it will sort it in a descending order. So I'm going to provide a function inside of the sort method, the math.random method. And this random method will generate a random number between 0 and 1. And the problem is all numbers between 0 and 1 are positives. So I'm just going to subtract from it 0.5. And now we'll have random negative and positive numbers being returned to our sort method, allowing our cards to be shuffled randomly. Now what's left to do is flip these cards after a certain period of time, and the only way I could think of doing that is with CSS. Now since this is not a CSS tutorial, I'm just going to uncomment the animation styles so that the cards flip after 2 seconds. And now if I save it and go check it out in the browser, the cards will flip after 2 seconds, but also when I click on them, nothing will happen. And now we will need to use JavaScript and React to flip these cards. Now in order to flip each individual card, we will need to know which card we are clicking on. And the problem is we cannot use the ID from the card to know, because these IDs are duplicated. The IDs are meant to tell you which cards match and not which cards we are actually selecting. And that is why we used the index. If I go back into the browser and select right click and inspect, I will notice inside of the console it will tell me, warning, each child in the list requires a key prop. And that is because every single card is its own component, and because it is being duplicated, React wouldn't know which one we are selecting if we actually select it. And therefore, we need to provide to this component a key, and this key has to be unique. If you are using something like a database, you will probably use its unique identifier, but since we are not using a database, I'm just going to provide to the card the key of an index. Now if I save it and check inside the browser, you will notice that the error message is gone. But this still does not resolve our issue, because whenever we click on the card, we want to know which one it is. So I'm going to provide another prop, just like card, but this prop will be index, and I'll provide to it the index. And because I'm providing the index as a prop, I will now be able to access it inside of my card component. Now it's time to talk about event listeners and functions in React. You see, whenever we click on this card component, we want to trigger an event. And this event will then compare the card to another selected card, and if they match, we win, and if they don't match, then the cards flip back. So it's easy, right? All we have to do is add an onClick event to this div tag. But hold your horses, it's not that simple just yet, because there is another issue, and that is whenever we want to compare this component with another component, we have to pass the information to the parent component, which is the cards.js component. So in other words, we should create the event listener in the parent component. But if we create the event listener in the parent component, we are also going to run into issues, and that is, how do we know which card we are clicking on? So in order to fix this problem, we are going to create an event listener in every single child component, which is the card component, and whenever this event occurs, we want to call a function inside of the parent cards component by simply passing a function down as a prop to the child component. So I'm going to create a function called clickHandler, and it will have an argument of the index. And all I want to do is just alert the index. Next, I'm going to pass down this function as a prop to the card component. So I'm going to create the clickHandler prop and pass down the function. Once that's done, inside of the card component, I'm going to receive the clickHandler function as a prop and provide to the card an onClick event, and this event will take in a function which is the clickHandler, and I'll provide to it the index. So this clickHandler function will run and the index will be passed to the clickHandler, which is located inside of the cards component. Now the reason why I called the clickHandler inside of this arrow function is because of this function call. You see, whenever we have a function in React inside of an onClick event and this function has these brackets, then this function will be called regardless of whether it has been clicked or not. So I'm just going to remove the arrow function just to demonstrate, and if I check inside of the browser, I will automatically get the alert showing up. So I'm just going to go back into my code and add the arrow function. And now if I check it inside of the browser, you will notice I will not get an alert until I click on the card. And whenever I do click on the card, I will get the index of the card that I have clicked on. Now in this section of the video, we are just going to be doing a bunch of if statements because that is essentially how the whole card game will work. Hello, this is Future Me, and I want to show you the rules for the game so we can understand how to structure our code. You see, if I select any of these cards, I want to set the status of the card equal to active. And if I select the second card, which is also a match, then it will get a status of active matched. And whenever the status of the card changes, we want to also update the DOM so that the CSS style for the card changes, thus allowing the card to go from face down to face up. But if I select a card that has already been selected, I will get a message notifying me that the card that I have selected is already matched. And if I select the same card twice, I will get a message notifying me that the card is currently selected. If I select a separate card, and this one happened to be a match, sorry about that, but if I select two cards, whoa, again I am very lucky, if I select two cards that don't match, then in that case I will get both cards returning back to face down so I could find the cards that do match. Back to me from the past. So the first thing I'm going to do is inside of VS Code, I'm going to create a new state. And this state is going to have its initial value of -1. And I'm going to set the state equal to previous card state and set previous card state. So this useState hook is going to carry the state of the previous card. Now I also want to carry the index of the previous card, so I will also need to create a second state for it. But there is an issue when having two states, and that is whenever these states update, the DOM will update. So I want to have a state, but I don't want the DOM to update. In that case, there is a specific hook that we can use, just like useState, but it does not trigger a re-render of the DOM, and that state is called useRef. So I'm going to call in my useRef hook by importing it from React. Then I'm going to create a constant, and I'll call it previous index, and I'll set that equal to the useRef hook, and I'll provide as its initial value -1. Now the useRef hook is not like useState where it will return an array of a value and a function. The useRef hook will just return a value, and that value will be stored inside of a property called current that is located on this previous index object. Now we don't need to get into the nitty-gritty details of how useRef works. All we need to know is that useRef returns an object with a current property on it, and useRef is kind of like useState, except it does not trigger a re-render. To find out more about useRef, useState, and all the other hooks in React, I do have dedicated videos for them, but at the moment we are learning React and not React hooks, so no need to worry too much about it. Next, inside of the clickHandler, I'm just going to create an if statement. And inside of my if statement, I want to check if the index does not equal previous index dot current. So we're essentially checking if the player did not select the same card twice, then in that case we want to do something. Otherwise we just want to return an alert message saying card currently selected. Now this time we want to check if the card is face up or face down. So we're going to create another if-else statement, and if the card.status that we've just selected is equal to active and also matched, that means this card is face up. And if that is the case, we want to alert a message to the player saying the card is already matched. Otherwise, we want to check the final if statement. We want to check in this if statement if the previous card state is equal to -1, meaning the previous card state is on its initial value, then in that case we want to set the previous index, which is the ref state, equal to the index of the card that we have just selected. We also want to take the card that we have selected status and set that equal to active, but we don't want to set it equal to matched, because we're not sure if it is matched yet or not. Then we want to set cards, which is the card's state, equal to an array, and we want to destructure the card state into it. And finally, we want to set the previous card state equal to the index. Otherwise, if the previous card state is not -1, then we want to set the previous index.current, which is our useRef, equal to -1 all over again. So we reset the game back to the way it was. And also we want to check something else. And we are going to create a separate function for it. And what we want to check if the cards are a match. And in order to check this, I'm going to create a function called matchCheck that takes in one argument, and that is the index of the card that I have selected, which will be the current card. So I'm going to create my matchCheck function, and this function will accept the index as an argument called current card. And the matchCheck function will also have an if-else statement inside of it, and I'm just going to check if the current card's ID is equal to the previous card's ID. Then in that case, I'm going to set the previous card's status equal to active and matched. I'm also going to set the current card status equal to active and matched. Then I'm going to set the previous card state to -1 so that we repeat the process and select the next card. Then if the current card's ID does not match the previous card's ID, then in that case I want to set the current card status equal to active. Then I also want to update the state of the new card status. Then I'm going to create a set timeout so it takes time for the cards to flip back to normal. And I'll just allow it to wait 1 second. And inside of my set timeout, I'm going to set the previous card status to -1 to reset it. I'm also going to set the current card status equal to unmatch, and the card's previous status will be also set to unmatch as well. Then I'm going to make sure to update the state again and update the cards back to their face down state. And now as a final touch, I'm going to go back into the card.js file and update the card component. You see, the game now is currently fully working, but there is still one problem, and that is the class name of the card is not being updated. So I'm going to set the class name equal to curly braces, and whatever goes inside the curly braces will be dynamic, and I'm going to provide to it a template literal. Inside of the template literal, I will leave it as card, but then I will do $curly braces to inject into the template literal the card status. And now if you open up the browser and refresh the page, you will now be able to play the memory game of Thrones. And I think I'm going to end things there, so don't forget to leave a thumbs up if you've enjoyed the video, subscribe to the channel for more content like this, and on that bombshell, thanks for watching.